When we talk about multi-protic acids and bases, we always have a question. Which is the principal species at some particular acidity? Which species of acid, base, or intermediate predominates under given conditions? Which of a simple example. What is principal form of benzoic acid at pH 8? Okay, this is benzoic acid. pKa of benzoic acid is 4.2. How we solve this problem? First, we look at Henderson-Hasselbalch equation. pH equal to pK plus log. Basic form, that's an ion, and acidic form. If these two are equal, pH is equal to pK. At pH values higher than pK, you'll have more base than acid. So, major species at more acidic pH than pK will be acid. Major species at more basic pH than pK will be an ion. More basic means higher pH. Now, for this case, pH 8 is obviously larger than pK, so the species dominating will be basic benzoate ion. You can draw the same thing here, looking at chart showing that pK will be for this particular acid at pH 5. So pK 5, you have 50-50 equal concentrations of acidic and basic form. At pH above 5, you'll have basic form predominant. At pH below 5, you'll have acidic form. And you remember that 1 unit of pH you'll have 10 to 90, and at 2 units of pH you'll have 1 to 99. And the same from this side. Now, what will happen if I'll have two protons? I'll have two constants, pK1 and pK2. At pK1, concentration of double protonated species will be equal to concentration of once protonated. At pK2, you'll have equal concentrations of species protonated only once and species completely deprotonated. These are equal. Maximum of HA minus will be between these two at pK1 plus pK2 divided by 2. So, at pH below pK1, I have two protons. Between pK1 and pK2, I have only one proton in here. Above pK2, I'll have no protons at all, complete deprotonation. So, by looking at constants and knowing pH, I can say which form will be predominant. More complex case with 4 possible species, arginine. So here we have completely protonated form. At pK1, it becomes once deprotonated. This proton is gone. At pK2, I have one more proton gone. And at pK3, the last proton is coming from here, giving completely deprotonated. Now, keep in mind, there are still hydrogen atoms in this molecule. They simply cannot dissociate. So the question is, what is the principal form of arginine at pH 10? Now I'm looking at pKs. 10 is between 899 and 12.1. So what species is predominant between this and this point? It will be a neutral molecule of arginine. Why I'm saying it's neutral? Because it's 1 minus, 1 plus. Total charge of this species will be 0. Next question. What pH does H2R plus equal to Rg minus? Now, when we have equal concentrations of this to this, it's condition of maximum of intermediate form. So the form intermediate between this form and this form is this one, and maximum will be at pK 2 plus pK 3 divided by 2. You can take average 9 plus 12 divided by 2 will be 10.5. More general case of triprotic system, say for phosphoric acid, is given on this diagram. So below pK1 you have H3A in case of phosphoric acid, H3PO4. At 215 you have equal concentrations of H3A and H2A minus. In our example, H3PO4 and H2PO4 minus. At pH equal 1/2 pK1 plus pK2, I'll have maximum of concentration of dihydrogen phosphate. This will be predominant for 100%. Now at pK2, I'll have equal concentrations of H2A minus and HA2 minus. So equal concentrations of dihydrogen phosphate and monohydrogen phosphate. Next, area of predominance of hydrogen phosphate. At pH equal pK2 plus pK3 divided by 2, I'll have pure HPO4 minus right here. And then we are coming to pK3, where concentrations of hydrogen phosphate and phosphate ions are equal. And this is very high pH 12.15. Above this, predominant form will be pure phosphate PO4 3 minus, no protons left. Similar considerations can be given for any triprotic acid. Same approach can be continued for tetraprotic, pentaprotic, and so on, as many protons as you want, as you need. Proteins, as an example, may have thousands of protons on one molecule.